Hey everyone, in this video we are continuing lesson 6.1. So what we talked about in the last video was about monomials. They're just one term, like all of the variables are stuck together. What we're going to be talking about today are polynomials. So we have more than one term. So a polynomial is when we add or subtract several monomials together. Now, if we look at polynomials, we'll normally have lots of different exponents. The highest exponent is what we call the degree. So if the highest exponent is 5, we would say that that polynomial has a degree of 5 because it's kind of the most powerful. And when we write polynomials, it's always important to write them in descending order. That means that we have the highest exponent first, like x to the 5th, then x to the 4th, x cubed, and so on. We don't have the numbers all mixed around. When we name polynomials, they get a name based on two things: their degree and their number of terms. So we're going to go over here and label these polynomials. If the degree is 0, meaning there's not any x's or variables at all, we just call this a constant. If the degree is 1, so like 2x, that is a linear, just a straight line. If the degree is 2, that's a quadratic. We just spent an entire unit learning about quadratics. If the degree is 3, that would be a cubic polynomial. 4, quartic. And the degree of 5, quintic. After that, you probably won't see very many examples after that. Now, if it just has one term, that's what we call a monomial. Two terms would be a binomial. Three terms, trinomial. And after that, we really don't give them a specific name. I mean, if you Googled it, you might find that it's something, I don't even know. But for this class, just write polynomial. So let's look at some examples. Number 9. That one, I only have an x, and that's x to the first power. So the degree is 1, making it a linear. And I have 2 terms, a linear binomial. Number 10, my degree is 5. And I have 3 terms. So a quintic trinomial. 24. I don't have an x at all, and it's just one term. So it's a constant monomial. Number 12 would be a cubic polynomial. Number 13, would be a quadratic trinomial. Number 14, that would be a quartic. And it's just one term, monomial. Number 15 says, give an example of a cubic binomial. So I might have x cubed plus 1. 35x cubed plus 2x squared. Both of those would be examples of a cubic binomial. Number 16, give an example of a linear monomial. So 592x, or you could just say x. All right. We're going to be practicing adding and subtracting polynomials. So what I like to do is I like to rewrite mine and I like to stack them. So we write the first one, 3x squared plus 11x plus 4. And I'm adding this one. So that would be a negative 5x x squared and negative 13. And so when I add, just add straight down. 4x squared plus 6x minus 9. Number 18, same thing. 5x cubed minus 2x squared plus 4. But this time it's subtraction. And when you do subtraction, you have to distribute that negative, making this a negative 2x squared, a negative 2x, and I'm just going to write it out here because I don't have any other like terms, and a negative 17. When you distribute, that makes it a plus. If you distribute, you don't still subtract. The distributing takes away the subtraction and makes it an addition. So this would be 5x cubed minus 4x squared minus 13 minus 2x. But we have to make sure to write it in standard form, so this negative 2x needs to move over. 5x cubed minus 4x squared minus 2x minus 13. So remember, if it's a subtraction and you change all of the signs in that second polynomial, that turns it into a plus. I didn't do negative 2 minus negative 2. I did negative 2 minus 2. So be careful. Number 19, or this next section, is multiplying polynomials. Now, we've got a few different ways you can do this. If you don't have a lot of terms, then I would just double distribute, meaning we take the x and we multiply it by everything. So that would be x cubed plus 2x squared plus x. And then we take the negative 7 and multiply it by everything. That would be negative 7x squared negative 14x, and negative 7. And then we add or combine our like terms. X cubed minus 5x squared minus 13x minus 7. Notice when I did my second row, I stacked my like terms. I didn't start putting the negative 7 over here. Stack your like terms and it'll make it a lot easier when you go to combine at the end. Now number 20, we've got some multiplication and then some subtraction. So let's start with this part right here. Let's do this one first. All right. So 2x times 4 is 8x. Then we have negative 18x squared. Then we have 4. And we have negative 9x. So this makes negative 1x minus 18x squared plus 4. And then we can distribute this negative 2x and combine it with the previous thing that we had. So this is a negative 6x squared. And that would be negative 22, x. So this makes negative 23x minus 24x squared plus 4. And then put it in the correct order. Negative 24x squared minus 23x plus 4. You could have possibly done this a different way. If you did that, that's fine, as long as you get the same answer at the end. Number 21, 2x plus 5d cubed. Now, I don't just cube each of those. Nope. This is like 2x plus 5d times 2x plus 5d times 2x plus 5d. Yeah, it's a lot. So let's start with these two. All right. This would be 4x squared plus 10xd plus 10. Now let's keep our variables in the same order. 10xd plus 25d squared. We have like terms. 4x squared plus 20xd plus 25d squared. And then I still have to multiply another 2x plus 5d. So that would be 8x cubed plus 20x squared d This would be 40x squared d plus 100x d squared. And then we got to multiply the 25d squared. So that would be 50 xd squared and plus 125 d cubed. Shoo. Combining like terms, 8x cubed plus 60x squared d plus 150x d squared plus 125 d cubed. And this is the correct order because if we look at our x's always get smaller, and that's fine to write it that way. All right, now number 23, I am multiplying 3 terms by 3 terms. It's really easy. If you looked at my last one, it is so easy to get it all mixed up. Look how messy that one looked. I'm going to show you a way to do it, and it's a lot less messy. So I'm going to make a 3 by 3 square thing. So, because I'm doing 3 by 3. This is just going to help me stay organized and make sure that I don't miss anything. And so my first one is 3x squared minus 4x plus 1. And then my other one I'm going to write across the top. 2x squared plus 5x and minus 9. And so inside my table, for example, this first box right here, we multiply what's to the left and we multiply what's above. So that would be 6x to the 4th. And so if I go across that top row, I'm multiplying everything by 3x squared. So the next one would be 15x cubed negative 27x squared. Now my next row I'm multiplying by negative 4x. So negative 8x cubed negative 20x squared 36x. And then my last row, I'm multiplying everything by 1. 2x squared, 5x, and negative 9. Then from here, when I write out my answer, a lot of times, not every time, but a lot of times, your like terms will be there in kind of diagonals. So I only have 6x to the 4th. But then I have x cubes that I need to combine. That would be plus 7x cubed. And then all of my x squareds, negative 27, negative 20, and 2, that's negative 45x squared. And then my next one would be plus 41x. And then I just have the minus 9. And that's my final answer. You can always use this method. You can always do the box. I personally prefer that. I would use it most of the time. I probably would have used it in number 21, especially for this second part. I just didn't have a lot of room to do it. All right, number 24. When we are dividing by monomials, we divide each term in the top by the bottom. So I would take 9x squared divided by 3x. So 9 divided by 3 is 3, and then x squared divided by x is x, minus 24 divided by 3 is 8, x squared divided by x is x, and 3x minus 8x is negative 5x. So number 25, we got 3 things that we're each dividing by 2ab. So the first one, 14 divided by 2 is 7. And then I've got a cubed, b squared, minus 10 ab, and everything cancels. That doesn't, like 2ab divided by 2ab, that's 1. Don't just leave that off. If you have 5 divided by 5, that's 1, not 0. All right. Let's divide by 3x squared. That would be 10x minus 4, the x squareds cancel, plus 3x to the negative 1 power, or which is really 10x minus 4 plus 3 over x. Because remember, anything with a negative exponent, you move that variable to the bottom. That 3 did not move, just the x. Number 27, we would have 5m n to the negative 1, minus 3, the m's cancel, n squared. But we got to make sure we move this n because it has a negative exponent. So 5m over n minus 3n squared. I know that was a lot, so we'll do some practice with this, and then hopefully after that you'll start to get it down, because it is a lot of stuff here, this first little bit. If you have any questions, let me know. Have a great day.